Hi friends, now we are going to solve the second and the last part of question number 5. So our question number 5 is with reference to Turing machine defined with suitable following. Firstly, we have to explain what is the DTM, then NTM and then LBA. So let's understand what is DTM. So DTM stands for deterministic Turing machine. Think of DTM as a very strict rule follower. Here is a breakdown of its key aspects. Firstly, its components. So its components are firstly finite state control. This acts as a like the brain of the machine, keeping track of the current states. And the second is read write head. This head interacts with the infinite tape, reading symbols and writing new symbols as needed. Now the third component is tape. It is an infinitely long tape divided into squares, each containing a symbol from the machine's alphabet, including blanks. And the operations on Turing deterministic Turing machine is firstly the machine starts a designated initial state and reads the symbol on the tape under the head. The second operation is based on the current state and the symbol read. The machine consults its predefined transition function. Then the third operation is the transition function dictates three actions. First action is write a new symbol on the tape square currently under the head, then move the head one position left or right on the tape, and then enter a new state for the finite state control. And the seventh step 2 and 3 are repeated until the machine reaches a designated acceptance state or a rejecting state on the input, signifying whether the input is accepted or rejected by the language the machine recognizes. Now the understand of NTM. NTM stands for non-deterministic Turing machine. So its components same as DTM, a finite state control, read write head and the tape. And the operations performed in NTM is first similar to DTM. The NTM starts an initial state and reads the symbol under the head. Then the NTM transition functions can have multiple possible outcomes for given state and symbol combination. Then instead of following the single path, the NTM can guess and explore the multiple paths simultaneously. It creates copy of itself for each possible transition, essentially trying out all options at once. Each copy then continues on its own path following the deterministic rules like a DTM. The NTM is considered successful if at least one of its copies reaches an accepting state. Any path leading to a rejecting state is abandoned. Now the last is LBA. LBA stands for linear bounded automata. So what is the linear bounded automata? A linear bounded automata (LBA) is a type of automata that falls between the capabilities of push-down automata and a Turing machine. It is just like a Turing machine with a limited memory, specifically restricted to the length of the input string it's processing. So components of linear bounded automata are similar to the finite automata like Q, sigma, del, Q0, and F. Finite set, these are the finite set of states represent q represented by q represent the different configuration of LBA can be in. Then the next is sigma, which represent the input alphabet symbols the LBA can read from the input strings. Then third, the tape alphabet, it is used for stack symbol the LBA can read, write and erase the tape. This can include the input symbol as additional working symbols. Now the transition function del define how the LBA transition between states based on the current state. The symbol read from the tape and the symbol to write on the tape. Then six is initial state represented by Q0. It is the starting step of the linear bounded automata. Then the last is final state that signifies successful processing of the input strings. Thanks.